Greetings, guys. Let's talk about this little section here on page 195. 195, 59 to 76. Well, I'm going to actually do a couple of these for you. So the ones I do, you definitely do not have to do. But the hard part about what we're about to do is sometimes understanding what the heck they're talking about. So this is our very first journey into trig identities. So what they're going to do is they're going to give us a couple little baby steps going forward until they kind of throw us into the deep end of the pool. So it says here in the instructions, write each expression in terms of sine and cosine. Okay, so right there, I'm going to try and make everything into a sine or a cosine. And then what do they want me to do? Simplify it so that no quotients appear. So that means they don't want any fraction answers. And all functions are of theta only. So here's the deal. Let's take a look at what that is actually trying to say to us, because it's very complicated sounding. So while I go through these next four examples here, by the way, this is page 195 in your book. Here's the answer key. Take a look at the answers. What they mean is all the answers are just written in terms with a theta, or they turned out to be like a regular old number. Like problem number 61, the answer is 1. Problem number 62, the answer is 1. But otherwise, they have a theta in them, and not one of these answers is a fraction. There's no quotient. So, for example, I know that tangent of theta could be written like this. This is one of our identities from the first lesson. They don't want to see this. They're like, if you have sine theta divided by cosine theta, let's just call it tangent. No quotient answers. So let's play. Let's just play. I'm going to show you the first one is number 60. Now, what do they say for an answer? Just so you know. Ooh, number 60, the answer is sine theta. That's what it says here. That's the answer. So, how did they get there? Well, they said first things first. Write everything in terms of sines and cosines. So guess what? I don't even have to touch this guy. He already says cosine theta. So I'm going to leave him alone. But when they write these functions right next to each other, it's the same thing it's meant all through math. If you write two things next to each other, it's multiply. So I am now going to take this tangent and say, you know what, tangent? I can rewrite you using only sines and cosines. So I'm going to take this is tangent. I'm just rewriting it. And I'm going to multiply it by cosine. And if it makes your brain feel a little better, you could do this. And then guess what? If I'm going to multiply two fractions and I have the same thing here as I do here, voila, I can cancel. So the cosines go away. I get sine theta over 1, or just plain old sine theta. So what do they want me to do? They want me to write, hang on, let me go up. They want me to write each expression in terms of sine and cosine and simplify so that no quotient appears in the final expression and all functions are theta only. Okay, so here we go. That is exactly what I did. I rewrote it with sines and cosines. I canceled that stuff out. The only thing that's left is a single function of theta. So, I feel pretty good about number 60. Nailed it. Let's look at another one. My second example is problem number 62 because I want to make sure that you guys get this concept. I am going to rewrite every single thing here with sines and cosines. So this guy right here, cosecant. Remember, that's a reciprocal function. I could rewrite that as 1 over sine theta. That's what that guy is. But he's right next to cosine theta. So I am going to write cosine theta next. Times, well, we just used this one. We just used this guy where we went, hey, I can make you say sine theta over cosine theta. And you know, I'm just going to stick a 1 on the bottom here because I can. So the deal is I can cross cancel. I could say cosine cancels with cosine. I totally could. And even though they're distance apart, this guy is still in the bottom. This guy is in the top. Well, heck, what happened? It looked like I got rid of everything here. So I have 1 over 1. Or I could just say 1 is my answer for this one. So let's go look at number 62. Number 62, oh, there it is. Try look, huh? 62 is 1. So let's just keep playing. This guy right here, secant theta minus 1 times secant theta plus 1. Now, I just want you guys to get this. Sometimes in the book, they have something and they'll say, perform the indicated operation. Perform the indicated operation. Well, what's the indicated operation here? What does it look like they want me to do? They want me to multiply it. Looks like I could FOIL this thing. It does. I could multiply it. So I am first going to tell you that the instruction said rewrite everything as sines and cosines like that. So you know what? I'm going to do it the way the book asked me to do it. But then I'm going to come back and I'm going to show you it's not always the easiest way. Secant theta times secant theta. Guess what I'm about to do? The indicated operation is FOILing here. I would end up with secant squared theta. Then here I would multiply that times that. I'd get what? Plus secant theta. Then here, what would I get? Minus secant theta. Here I would get minus 1 times a 1. That's a negative 1, it looks like. Hey, do you guys see this? This is going to cancel. That's going to cancel right there. It is. And I end up with a secant squared minus 1. Now, I know I didn't turn anything into sines or cosines. I didn't. Because I'm going to show you that I could do this thing without doing that. See, I know something about secants and ones and things like that. See, I could rewrite this. I could say this is 1 over cosine squared theta minus 1. I could, but guess what? What does that get me? It doesn't get me anywhere. It really doesn't. I would say, geez, I don't know what that could possibly be. Well, tan in 1 sec. Tan in 1, whoop, duh. I said it, but I didn't write it. Second. I don't know if you guys remember this from the very first video. This is one of our dudes. Tan in 1 sec. Tangent squared plus 1 is equal to secant squared theta. So why would I want to do this? Why would I want to do it this way? I don't know about you guys, but if secant squared theta is the same thing as this, couldn't I just substitute that? Couldn't I just substitute that? Couldn't I just say, hey, I'm going to write tangent squared theta plus 1, that's what this is, minus 1. Minus 1. See, all I did is I substituted that in, and then what happens? Those cancel. What do I get left with? It looks like I get tangent squared theta left over. That's what it looks like. That's the answer. See, here's the thing about this. They don't tell us, you know, where the end of our journey is, but our journey ends when we have, I have to scroll up, pardon me, I got to scroll up quick to show you. Our journey ends when we have written that there is no quotient in the final expression, and all functions are that of theta. Meaning you don't have a negative theta in it, okay? You don't have a fraction in it. Well, my answer was tangent squared theta, so I think I achieved the goal. And what is the answer? Tangent squared theta. Now, guys, the hardest part about what we're doing in this section, and this is the hardest section, I think, is we're learning how to play with these identities. See, they might give us something that doesn't look like something we have memorized, and then lo and behold, it becomes something that we have memorized. But I gotta warn you, this one, number 68, I didn't want to give you guys this one to try on the assignment, and you'll see I skipped a couple. Because this one, I could have done it by changing everything into sines and cosines. I really could have. But that would have put me right here. And this, well, why would I want to do that? Why would I want to rewrite this part like that? It makes no sense to me, because all I really want to do is simplify it so there's only one trig function left if I can get it there with a theta. So I broke the rules a little bit. I did not write everything as sine and cosine in this one. I didn't. You don't have to either. But you know what? Take a look at the first one I did. That was totally the way to go. That made it so easy. The second one we did. Oh, that was totally the way to go. Rewrite it with sines and cosines. That would have been the best thing to do to get it to work out. This one, not so much, because I was able to do it using tan and 1sec instead. Let's look at the last one. This is the one that says cosecant theta minus sine theta. Now, here's the deal with this. Perform the indicated operation. I just want you to kind of think about that. The last question we did, perform the indicated operation, was foiling. What's the indicated operation here? It's subtraction. But if I'm going to subtract two things, well, this is where they have it kind of, they're hiding it right in front of me. That is 1 over sine theta minus sine theta. Well, wait a minute. This guy has a denominator of 1. I would need to get common denominators. So I'm going to say, you know what? You guys need common denominators. So I'm going to give this guy a sine theta. That means I got to give this guy a sine theta. And that will give me on the top. Ooh, remember this from rationals section? That'll give me in the numerator 1 minus sine squared theta. The whole thing has a denominator of sine theta now. Hey, the top part is a binomial. The bottom part's a monomial, so I don't get to cancel anything. But you know what I do get to do with this? I get to take a little detour here, kind of like I did with tan and 1sec. Hey, this guy right here, you know what I know? I know that cosine squared theta plus sine squared theta equals 1. That's a Pythagorean identity. And if I were to move this to the other side, like this, right? If I were to take this away, do you see what I see? 1 minus sine squared theta, 1 minus sine squared theta is equal to cosine squared theta. So this whole top part becomes cosine squared theta. What's on the bottom? I never changed the bottom. It's sine theta. Now, here's the thing. It's pretty, but it's breaking the rule they set forth. They said, hey, guess what? We don't want any quotients in our answers. And this right here is a quotient. It is. Now, the thing is, this cosine squared theta over sine theta, I am going to tell you that the answer they have is cosine theta times cotangent theta. That's the answer they have in the book. Now, wait a minute. Do you see how this answer right here is in terms of theta? It is. Do you see how this answer right here does not have a quotient? No, it doesn't. It's also, you know, trig functions, single trig functions. So that's the answer they have. How did they get there? How did they go from here to there? Well, this is why I picked out number 74. Because sometimes the things they want you to see are not quite obvious. Cosine theta times cosine theta is cosine squared theta. I'm going to put a sign on the bottom here. I'm going to put a 1 on the bottom here. And then I would say, didn't I just take what they had here and write it as two separate chunks? I think I did. I wrote it as two separate chunks. And in the book, this thing is called cotangent theta. And in the book, well, cosine theta. They just happen to write it like this. Because you can write multiplication in any order you want, and it doesn't matter. Right? Multiplying things doesn't matter the order. 2 times 5 is going to be the same thing as 5 times 2. It's going to be the same thing. 2 times 5 is 5 times 2. So, let's see here. That was my last example. Here's the deal. I'm going to skip over this one little tiny bit here where they have the negative thing right here. Not going to do this one. This one's a little rugged yet. Okay? Not going to do that one. Also not going to do this one. A little bit rugged. But I want you to remember something. Like problem number 69 here, tangent of negative theta. Isn't that just the same thing as negative tangent theta? So technically, I could rewrite the top part as 1 minus tangent theta. I could also say negative tangent theta on the bottom if I wanted to. I could. I think I could. So the deal is, what they want from you guys is, they want you to try and rewrite things in sines and cosines. Then they want you to perform the indicated operation, like maybe multiply here, right? Maybe that's what they want. Maybe FOIL right here. Maybe that's what they want. Okay? But what they want you to do is then try to simplify everything down. So you don't have any quotients, and you just have regular theta, no negative thetas. But these ones we're going to come back to. We'll do these later. I want you guys to actually try the following questions. I want you guys to do, this is page 195. We're going to do these. 59 to 70. And then we're going to do 73, 75, and 76. Those are the ones we're going to attempt. Now, here's the thing. You really don't know what you're doing. You're flying blind a little bit because you've been thrown into this world where we can substitute different things in. But take a look at what you're aiming for. Let me erase those marks I made on the answer key for you. Get them out of the way. But what you're aiming for is these answers right here. So I always say when you're learning how to do this for the very first time, know what your answer is that you're working toward so that you know it when you get there, so that you understand when you have arrived at the answer. All right? Now, some of these are going to be easy peasy, quick, and some are going to take you a little bit of thought. So, anyway, I have a cheat sheet for this, but I'd rather have you guys come in the room and ask for help. So, remember, I'm always in the Zoom room. Come in, check it out. All right, so that is the end of this one. We got one more set of IDs before we go big time. I'll catch you guys later. Bye-bye.